Okay, so first up in this one is evaluating a table. So let's look at that. So we have this f of n equals a number. So underneath here, what I want you to do is I want you to write this out. When given n's number, we look at the n value and find its f of n partner. Okay, so if we are given this number, n, if we're given n, then we have to find its f of n partner. Next up we have when given f of n's number, we look at the f of n's to find the n partner. So if we're given this, just the number, not that it just says f of n equals some number, then we have to figure out what our n value is. So if you have this written down, don't forget you can pause this video. We're going to scoot over now. So we have this table, it's very long, and we got to notice here that our n's are the top row, our f of n's are the bottom row. So this first one here we have evaluate. For number 1 we have f of 3 equals something. Okay, so what this means is we're looking for when our n equals 3 and what the f of n partner is. So when n equals 3, so in my n row it equals 3, our f of n is 15, so 15 is our answer. Next up we have when when we have f of negative 2. So when our n value is negative 2, its partner is 0. Its f of n partner is 0. Then we have when f of 0. So when n is 0, so when our n value is 0, let's not circle that, Miss Rawolf. When n equals 0, its f of n partner is our answer 6. Okay, because remember, usually when we write this, it's f of n. Well, now we're given the n number, so we have to look on our n column to figure out f of n's value. All right, here we go. Now we're going to solve. We're going to figure out n's number this time, so we're doing the opposite. So this time we know our f of n is equal to 3. So in our f of n row, we're looking for 3. Here it is. Its n value partner, in this case, is negative 1. So n is equal to negative 1. Next up, we have when f of n is equal to 18. So looking at my f of n row, we find 18. Its n partner is 4. All right, next up we have when f of n is 0. So looking for 0, here it is. And its partner is this n value, negative 2. All right, and that's how you do that. Let's look at the next section. The next section is evaluating an explicit function. So let's go look at that. So underneath in this box here, you're going to write, when given f of a number, we take this number, and again, we got this number from right here, when f equals a number, we take this number and replace all n's in our equation with this number and simplify. So pause this video, finish writing it, and we're going to move over to examples. So, evaluate f of n equals 6 minus 3n. So here's an n, here's an n. We will replace them with the same number. So we have f of 3 equals, well, 6 minus 3, and then we'll replace this n in the back with times 3. Okay, so I replaced this n and this n with this number 3 that we were given. Okay? This one was already replaced. We had to replace the back one. This leaves us with 6 minus 3 times 3 is 9. 6 minus 9 is negative 3. So f of 3 equals negative 3. Let's look at the next one. We have 6 minus 3, and this time we have to replace n with negative 2 because that's what we were given. So let's evaluate. Negative 3 times negative 2. Well, two negatives make a positive, so now we have plus 6. 6 plus 6 is 12, so f of negative 2 equals 12. Looking at the next one, we have f of 0, so we're going to replace our n with the number 0. So we have 6 minus 3 times 0. Negative 3 times 0 is 0, so now we have 6 plus 0. 6 plus 0 gives us 6, so f of 0 equals 6. Now let's evaluate with a geometric explicit. So let's make sure first, this number 2 here, it's supposed to be a positive 2, a positive 2, a positive 2. Then let's start evaluating this first one. So we are given that our n value is 3. So using this equation, we're going to replace these n's with the same number. So 6 times 3 to the third. Well, 6 times 3 to the third. Well, 3 to the third is 27, so we have 6 times 27. Ms. Rawolf, how did you get that? Remember, this means 3 times 3 times 3. We multiply this 3 times. 6 times 27 is 162, so f of 3 for this particular explicit is 162. Then we have f of positive 2. So we're going to have 6 times 3 to the second power. This means 3 times 3. 3 times 3 is 9. So now we have 6 times 9. 6 times 9 is 54. So f of positive 2 equals 54. Next up we have f of 0. So this means 6 times 3 raised to the 0 power. Anything raised to the 0 power is 1. Don't believe me? Check your calculator. So 6 times 1 equals 6. So f of 0 equals 6. All right. Next up, we have evaluating a recursive function from a table. I want you to write underneath in the box here is when given f of a number, we take this number, okay, the number here, and replace all n's in our equation with this number, and then we'll evaluate using our table. So let's look at this. We are given this equation f of n equals f of n minus 1 plus 3, given that our table started with f of 0 equals 6. So here's how our table starts. We're going to replace all of our n's with the same number. In this first problem, our n value is 4. So what we're going to do is we're going to have f of 4 minus 1 plus 3. Miss Rawolf, what? We already were given this n. We just plug in for the n over here. So this gives us f of, well, 4 minus 1 is 3. So f of 3 plus 3. Well, what is f of 3? Using those skills from the earlier, f of 3, well, we're given the n value 3, which means its f of n partner is 15, okay? We're using the stuff we learned at the beginning of this lesson. So f of 3 is 15. Well, now we have 15 plus 3. And what's 15 plus 3? Well, that gives us 18, right? And if we were filling out our table the rest of the way at time 4, This tells us we're adding by 3 down our table, so 15 plus 3 is 18. That is what the recursive means, y'all. All right, let's look at this next one. Now we are given n equals 5. So we have f of 5 minus 1 plus 3. Well, 5 minus 1 is 4. So now we have f of 4 plus 3. Well, we know what f of 4 equals. We just solved for that. But if we look here at our table, f of 4, our n value equals 4, its partner is 18. So this means we have 18 plus 3. 18 plus 3 is 21. Right? And if we were working on our table, to get down another step, we would add 3 again, and 18 plus 3 gives us 21. Again, that is what the recursive formula does, y'all. All right, now I'm going to show you how to put this into your notebook and fold it correctly. Evaluating with function notation. This is going to be page 12. Here's the title. We are going to glue it in on page 12. We just fold it in half, long ways, and then we cut along the dotted dashed line so that it looks like this.